Okay, let's talk more about simplifying radicals. And I want to scroll up here to some things we talked about earlier. When we have radicals, sometimes it's easier to write them in exponential expression and solve as opposed to trying to simplify them in radical form. Here's a prime example. We cannot divide these two radicals because they have different indices. This is a 4 and this is an 8. However, if we're able to take those and write those into exponential form, then we have things with the same base, and we can subtract the exponents. So this would be a great problem to copy down, and this would be a good little note to highlight in your Cornell notes. All right, after you've gone ahead and copied that down, we're going to flip over to another section here. Again, this is the division where it's easier to simplify from radical to exponential, then perform our operations. Let's take a look at a couple others here. Here is a product or quotient problem for some of these. Here we're going to go ahead and multiply, but if you look at the index, this is a 2, even though we don't write it again. This is a 4, so our indices are different, so we cannot multiply these as we normally would with radicals. But they have the same base, so let's write them with exponential expressions. 3 to the 1/2 and times 3 to the 1/4. Same base, add the exponents. Sometimes these are easy fractions, but think about money. For example, 50 cents plus a quarter, that's going to give us 75 cents or 3/4. And let's try and simplify that further by writing this back into radical form. My index is 4, radicand is 3, and then my power is 3. So I'm going to have 3 to the third here. Well, 3 to the third is the same thing as 27, right? So let's see if we can simplify this. 4th root of 27. Well, 27 is not a perfect 4th root, so this is as simplified as you can get. Let's take a look at another quotient problem. Again, we're probably going to write this as an exponential form. X to the 3/2 over x to the 2/3. Subtract the exponents because they have the same base. 3/2 minus 2/3. And we're going to go ahead and use that butterfly method that we talked about earlier. And we're going to have 9. 3 times 3 is 9. Minus 4. All over, multiply these two together, 6. So that's going to be, 5/6 is going to be our exponent. And that's going to be x to the 5/6. If they want you to write this in radical form, again, our index would be 6. And that would be x. And you can write the 5 here. Or, remember, there's a different way of writing this. Index of 6, x, and then raise the whole thing to the 5th power. These are both the same, just a different way of writing it. Last one, we've got the index of 2, index of 3, can't multiply them in radical form, so we're going to write these in exponential form. 7 to the 1/2 plus, 1/3. And just like we did with the other one, we're going to use a little butterfly. 2 times 1 1 times 3, and then we're going to multiply 2 and 3 together. 7 to the 3 plus 2 over 6. Again, you can write that in radical form, index of 6, 7, the power of 5. So I think we also talked a little bit about the couple methods here that we learned yesterday. Let's take a look at some of these negative radicals that we might have worked on. The first thing they did was they converted the 2.5 to a fraction. You can use that on your math frac button for your calculator. And then simplified 16. It went to 16 went to 2/4, or excuse me, 2 to the 4. Now the question is, why would they want to do that? Well, what do you do when you have a power to a power with your exponents? You go ahead and multiply them. So that's going to be 4 over 1 times negative 5 halves, which is going to be 20 halves, otherwise known as 10. Don't forget your negative. And then you're going to have 2 to the negative 10. Remember, the negative exponent makes you move it from the top to the bottom or bottom to the top. And then you get to do some quick simplifying right here with 2 to the 10th. I'm assuming that we're not going to carry that out on our in our heads. We're going to have a little bit of a calculator aid with that. But now let's take a look at another method. We had still 16 to the negative 5 halves, moved the exponents down to the bottom because it was negative, and then wrote this as a radical, index of 2, power of 5, simplified the radical, that's going to be 4 to the 5th power, 4 to the 5th, or 1 over 1024. Either one of these is fine. I think that this method seems to make more sense for more students. However, we're going to encounter this technique a little bit later in the year when we're talking about logarithms. So here are the other two methods, or here's the other methods in action. Again, they went ahead and wrote that in a base of 2, power to power, they multiplied the exponents. Here they just went ahead and wrote it in radical form, then simplified it from there. Let's try a couple of these on. Let's try a couple of these. Let's talk about 32 to the negative 3/5. I think it's easier to work with radicals first, so we're going to kick this down into the basement, 1 over 32 to the 3/5. Then write this as radical form, base of 5, or excuse me, a index of 5. And then we're probably going to go ahead and square, or excuse me, cube that. Now, the 5th root of 32, a little bit of algebra would get you down to 2. And so that's going to be, inside here is going to be 2, all raised to the 3rd power. And then 2 to the 3rd is 8. So we're going to have 1 over 8. Let's take a look at another one of these. 16 to the 3/4. Again, write it in radical form. Our index is 4. And raise that whole thing to the 3rd power. And 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is going to be 2. To the 3rd power, that's going to be simplifying to 8. Just a coincidence, I'm sure. Number 9, kick the exponent, or kick everything down to the basement here, your denominator. We're going to have 9 to the 3/5, or excuse me, 3.5, and we're going to go ahead and simplify this to 7 halves. So there's a 1 over 9 to the 7 halves. Write this as a radical. We're going to have 1 over the square root of 9 raised to the 7th power. And that's going to become 3 to the 7th power. Oops. 1 over 3 to the 7th. And a little bit of quick math here. We're going to have 3 caret 7. Well, we got some other stuff here, don't we? Clear that all out. 3 to the 7th. And we get 2187. That is our short video for tonight. Please feel free to go back over these methods on simplification, and we'll see you tomorrow and complete all the homework in class. Have a good night.